Namaskar, my dear friends. Let us talk about gate mathematics. In this session, we'll try to understand what is probability distribution. Okay, so there are a lot of distribution. We have binomial distribution, Poisson distributions, or geometric distribution, uniform distribution, exponential distribution, normal distribution, or Gaussian distribution. So all those are there. So let us list out those topics. Okay, so you can say that we have binomial, then we have Poisson, and then we have geometric. So all these are actually discrete, okay? Discrete distribution. And then we have some continuous also, that is called as, let us say, uniform. This is also called as rectangle, okay? Because of its shape. And then we have exponential, and then we have normal distribution, or it is also called as Gaussian. So these three are actually continuous. So most of the gate questions are actually limited to these six distributions, and many questions are coming every year from all the branches. Okay, so what you have to do is you have to give a continuous and like dedicated understanding, or your complete like dedication to understand this particular topic, so that you do not leave any questions. Okay, so let us start with one by one each of the distribution, and we'll try to find out mean, median, mode, standard deviation, expectation. All these things we'll try to find out for each one of them, and we'll try to understand the definitions as well for each of them. Okay. So let us start with first one, binomial distribution. So in binomial distribution, what happens is basically the binomial distribution is applicable for Bernoulli's trials. Okay. The binomial distribution is applicable for Bernoulli's trials. So what is that Bernoulli's trial? First of all, you have to understand Bernoulli's trial. So it tells that a trial which has only two outcomes, a trial which has only two outcomes. Either it can be true or false, okay? That is success or failure. It is not that you do not know whether it is failure or success. Either it will be a success or it will be a failure. Here probability of success is denoted by probability of success is denoted by P, and probability of failure is denoted by Q. Okay, so P and Q, two letters are there, a small p and a small q, such that my probability of success or failure, right? So success plus failure must be equal to 1, because either it is a success or it is a failure. It means it can be always 1. So what are the examples for this condition? You can take up some examples. Let us say, for example, tossing a coin. Tossing a coin. So considering the fact that it is unbiased coin, so either you can get head or tail based on your requirement, right? And then throwing a dice, or you have number of defective pieces, number of defective pieces. Let us say you have sent a lot of computers, and out of those computers either all of them will be fine or some of them may be defective. So this is how this particular binomial distribution is defined. All right. Now let us talk about its probability functions and all other different parts. So what we are going to talk about is, first of all, we are going to talk about probability function. So in this probability function, let us say we want to find out probability of random variable x, which is going to be r times success, is nothing but the probability of r success out of n trials. The probability of r success out of n trials. So you have trial n times and you want to get r times success. This is going to give you NCR p to the power r q to the power n minus r. So this is the formula that you have to remember. The probability of x equal to r is nothing but NCR p to the power r q to the power n minus r. Okay, where r is equal to either it can be 0 like no success, or 1, 2, 3 up to n, because it cannot be more than n. And here you have to remember always p plus q will be 1, because p is the probability of success and q is the probability of no success or failure. Okay, and in this case here it is called as some more terminologies are there like n and p. Okay, p are called parameters. N means number of trial is called as parameter, as well as probability of success is called as parameter. Q is not called because Q can be determined very easily, which is going to be equal to 1 minus P. So you can say that Q will be 1 minus P. Okay. Now let us talk about mean. So my mean, that is mu or expectation. Okay. I can write it down. That is going to be equal to nothing but your expectation of x, right? This is defined as summation of, what was that? Xi into P of Xi, right? Where I equal to 1 to n, you can say. So if you calculate this, you are going to get expectation of x for the binomial distribution is NP. Okay. So expectation of x is going to be NP. Understood? Now let us talk about variance. So we have talked about expectation of x. Then we can talk about variance. V of x. So the variance is actually going to be equal to NPQ. Then we talk about mode. So mode is going to be equal to, if you want you can calculate as well, like try to find out by yourself what is the probability NCR p to the power r q to the power r q to the power n minus r, and with that method you can try to find out, you will get NP. So I'm going to give you directly the results. Okay, mode is actually n plus 1 times p if n plus 1 p is not an integer, and it can be n plus 1 times p minus 1, comma n plus 1 times p if n plus 1 into p is an integer. It means what? The mode will be n plus 1 into p, otherwise it will be n plus 1 into p minus 1, comma n plus 1 into p. So this is how mode is calculated. Why don't you take a simple question and try to understand what it is? So let us say we have binomial distribution and the number of trial, for example, let us say the number of trial n is equal to 6 and the probability of success is 1 by 2. So q will be what? 1 minus p, that is going to be 1 minus 1 by 2, that is again 1 by 2. Okay. Then what will be the expectation? Expectation of x will be np, that is going to be 6 into 1 by 2, that will be 3. Variance will be what? So variance is going to be npq, that is 6 into 1 by 2 into 1 by 2, that will be 3 by 2, that is 1.5. And mode will be what? My mode is going to be equal to n plus 1 into p. So that will be equal to 6 plus 1 into 1 by 2, that is 7 by 2, which is going to be 3.5. So if this is not an integer, so this will be my mod, which is going to be 3. Or otherwise, if my n equal to 7, okay, if n equal to 7, then what will happen? P equal to 1 by 2. Then my n plus 1 into p is going to be 7 plus 1 into 1 by 2, that is 4. Okay. So you understood that like mode can be n plus 1 into p, which can be 3.5, and the greatest integer function of this, if it is not an integer, it means it will become 3. Got it? Now let us talk about another distribution, which will be Poisson distribution. Number 2, Poisson distribution. In Poisson distribution, you have to understand like how it is actually defined and what are the different things that we need to consider, right? So for example, I'll give you some examples so that you can understand what is Poisson distribution applicable for. So let us say the number of wrong calls to a mobile in a month, okay? Like a lot of spam calls comes up, right? So that comes under Poisson distribution because the number can be infinite, okay? So you can say number of wrong calls to a mobile in a month. Then you can say number of accidents on a highway in a week. Number of accidents on a highway in a week. Basically, how many number of accidents that are happening on a highway, that may be also infinite, or you do not know. This can be very random, okay? So that also comes under Poisson distribution. Few more example I'll write quickly so that you can have an understanding. Number of defective pieces in a box of 100. In a box of 100. Then number of bad checks issued to a bank. Number of bad checks issued to a bank. The number of printing mistake per page, like you're printing something, you're trying to type something and that is wrong, right? So number of printing mistake per page. So basically what happens is we generally apply Poisson distribution on very rare events under the following assumption. Okay. So what you can say that we apply Poisson distribution on a very rare event under the following assumption. So what are those assumptions that we have to list out? So number one is, like, first assumption is my lambda, which is which is going to be like parameter. So that must be NP, where N is the number of trials or number of events and P is the probability of success. And number two is P tends to 0 as my number of trials tends to infinity. Okay. It means there is a possibility that getting a accident on an highway is very, very rare, right? Like thousands or lakhs of vehicles are passing and out of that one or two accident is happening. So that is very rare, right? So this is how it works. Now let us talk about its probability, expectation, variance and all other parameters. So in Poisson distribution, you can say the probability function is this is called as, let us say, probability of x equal to r is actually defined as e to the power minus lambda, lambda to the power r by factorial r. Okay. So basically where r is nothing but the success, like 0, 1, 2, 3, 4, like that up to infinite. And you can say lambda is called as parameter. Sometimes people use e to the power minus k to the power r by factorial r. So that is different, not a problem. Next one is we have mean which is going to be equal to variance as well. So for Poisson distribution, mean and variance both are same and this is actually equal to lambda. And then we have a standard deviation. So that is going to be equal to a square root of lambda, right? And then let us say we have mod. So mod will be equal to greatest integer function of lambda if lambda is not integer. And otherwise it will be lambda minus 1 comma lambda if lambda is an integer. So you understood this, what is binomial distribution and what is Poisson distribution. So what we'll do is we'll try to take some questions and then we'll go ahead with geometric distribution. Okay. Or otherwise let me define geometric distribution also, because this is also discrete distribution. Then we'll take questions. So let us take third one, geometric distribution. So in geometric distribution, basically what happens is we have to find out the probability of first time success at kth attempt. Let's say you attempt k times and you are going to get first time success. Okay. So it is basically nothing but we find the probability of first success at kth attempt. Understood? So let us say what are the different parameters that we are going to see. My probability of x, which is going to be equal to kth attempt, that is going to be 1 minus or p into 1 minus p to the power k minus 1. Okay, where p is called as parameter of the distribution. P is called as parameter of the distribution. Hope you understood that we have to find out that we will get first time success in kth attempt. So the probability of x equal to k will be p into 1 minus p to the power k minus 1. Okay. Next is we have mean. So the mean will be nothing but, or it is also called as expectation. I can write it, expectation of x, that is going to be 1 by p, 1 by parameter. Okay. Then variance is, I'm not deriving anything because like we will be deriving wherever there will be a necessity. So these questions you can directly keep it as it is. So variance is 1 minus p by p square, and the mode is always 1, mode equal to 1. So this was all about geometric distribution. Okay. Now let us take few questions so that you can have a proper understanding that was asked in GATE. So in previous years, lot of questions are being asked from this discrete distributions. So let us take some of them. Okay, the question is, probability that a thermistor randomly selected, probability that a thermistor randomly selected from a production unit is defective is 0.1. Okay. The probability that out of 10 randomly, the probability that out of 10 randomly selected thermistor, 3 are defective. 3 are defective is. So what is the probability that you select 10 thermistor and out of that 3 are defective? So the options are 0.01, B the option is 0.057, and C 0.0107, and D 0.3. So you know that we have thermistors randomly selected from a production line, and its probability is 0.1. Out of 10 we have to see that what is the probability to get 3 defective. So it looks like whether you select one like a thermistor, it can be defective or it can be a good one. So it is to success or failure, right? So basically you can see probability of getting defective is actually your success. Okay. So my probability of success P is going to be 0.1, and Q will be 1 minus P, that is going to be how much? 1 minus 0.1, that is 0.9. Okay. Now you have number of trials which is going to be 10, and the number of successes that you have to find out is 3. So from Bernoulli's like a theorem or binomial distribution, what happens? The probability of getting x equal to r success, that is 3 success, is what? Let us say I will write it r first. Is NCR p to the power r q to the power n minus r. So from here you are going to get probability of x equal to 3 is nothing but 10c3 and p to the power 3, that is 0.1 to the power 3 into 0.9 to the power 10 minus 3. So that is going to come up as how much, can you tell me? 10c3 is nothing but 10 into 9 into 8 into factorial 7 got cancelled, 3 into 2, and this is 0.1 to the power 3 into 0.9 to the power 10 minus 3, that is 7. So if you calculate this, what you are going to get? You are going to get 2 4s are 8, 3 3s are 9. So if you multiply all these things, you are going to get 0.05739, or it is approximately 0.0574. Understood? So this was a very straightforward question. All right, let us take another question. This was asked in last year's GATE. The probability that getting at least 2 6, probability that getting at least 2 6 in throwing a fair dice 4 times. 4 times is. So it becomes very easy by like solving this using binomial distribution. Okay. So what happens is, you can see that a dice is there, right? So getting a success is what you know already. Like let us say P is equal to probability of getting 6. That is going to be what? 1 by 6. And Q will be what? 1 minus P, that is 1 minus 1 by 6, which is going to be 5 by 6. Right? Now, what is there we have? we have been asked that getting at least 2 sixes. It means I can get 2 sixes, 3 sixes, 4 sixes also, not a problem, because all the 4 times I can get all 4 sixes. So it is not limited. So my number of trials that is given here is n equal to 4, right? So I can tell my probability of getting at least 2 sixes is nothing but greater than or equal to 2. Okay. I mean, either I can get 2 6 or 3 or 4. So I can write it down. Probability of getting 2 sixes plus probability of getting 3 sixes plus probability of getting 4 sixes. Right? And then this also can be written as, let us say I can claim it like this, since we have to calculate like 1 2 3 probability, it might be little bigger. So to make it a small, can we write it down? 1 minus probability of getting 0 sixes plus probability of getting 1 sixes, isn't it? So if you do this, you are going to understand that if we find out what is the probability of getting 0 sixes and 1 sixes, it is very easy for me to calculate what is the probability of getting at least 2 sixes. Okay. So let us first calculate probability of getting 0 sixes or 1 sixes. So probability of getting 0 6s plus probability of getting 1 6s is equal to what? We have NCR P to the power R Q to the power N minus R. Let me write the formula here. Probability of getting R success is NCR P to the power R Q to the power N minus R. So from here we are going to get 4C0 and 1 by 6 to the power 0, 5 by 6 to the power 4 minus 0. Okay. Then plus 4C1, 1 by 6 to the power 1 and 5 by 6 to the power 4 minus 1. Okay. So from here we are going to get 4C0 is 1, right? So you are going to get 1 by 6, then it is simply 5 by 6 to the power 4 plus this is going to be 4 into and 1 by 6 into 5 by 6 to the power 3. So if we take 5 by 6 common, if we take 5 by 6 to the power 3 common, then what we are going to get? 5 by 6 plus this is going to be 4 by 6. So it is nothing but we are going to get 5 by 6 cube into 5 4 9, 9 by 6. So if we divide this, we are going to get, or let it be how much it is anyway, let me tell you. 3 3 is 9, 3 2 is 6. So 3 by 2 into 5 by 6 cube. Okay. So to get this probability of getting success more than, at least 2 times is what I can tell my, that implies my probability of getting success at least 2 times will be equal to 1 minus 3 by 2 into 5 by 6 cube. Okay. That's all. Is that okay? So you can very easily calculate what will happen. Just check once that calculation is correct or not. Like here we have taken 5 by 6 cube common, so it will become 5 by 6 plus 4 by 6. So 5 4 9, 9 by 6, that is 3 by 2, right? And this is going to be 3 by 2 into this. So it is going to be 1 minus 3 by 2 into 5 5 25 25 125 125 by 6 6 36 छक्का 216. So you calculate and get the answer. Okay. All right. Let us take another question. The question is, consider a cubic dice this was asked in last year's gate with opposite faces colored identically. With like R, G and B, red, green and blue. Okay. The dice thrown 3 times. The dice is thrown 3 times. Probability of getting red color at least 2 times is. Probability of getting red color at least 2 times is. So what is the probability that you will get red color minimum 2 times? Okay. So can you guys tell me? You have a cube. Okay. like it looks just like dice. And then we have RGB. Okay, so let us say we have, like a blue color and opposite faces are blue colored. Then we have red color, then opposite faces are red color. Then we have like green color. So green color is like a front faces is green color, front and back. Okay, that you can consider. That's all. So with this information, we are going to get what is the probability of getting red color two times, right? Or I mean at least two times. So can you tell me what is the success? Success probability will be, we have actually two faces red, right? So out of six faces, so 2 by 6, that is 1 by 3, and q will be 1 minus p, that is 1 minus 1 by 3, that is 2 by 3. So p and q is done. Now you know that we have three times. So basically the number of trials is 3 and r is at least 2. So 2 or 3. It can be 3 as well, like all the 3 times you get red. So I can say my probability of getting at least 2 times red is nothing but probability of getting 2 times plus probability of getting 3 times, right? So this can be written as 3c2 p to the power 2, right? 1 by 3 square into, let me make it 2 by 3 to the power 3 minus 2, that is 1, okay, plus 3c3 1 by 3 to the power 3 into 2 by 3 to the power 3 minus 3, that is 0. So with this information you are going to solve very nicely. 3c2 is how much? 3 into 1 by 3 square is how much? 1 by 9 into 2, so 2 by 9 3 is 27, plus 3c3 is 1, so it is going to be 2 by 3 to the power 0 is 1, so that is going to be nothing but 1 by 27. So this is nothing but 3 to the 6, so 7 by 27. So hope you understood how to get the particular probability required, right? Let us take another question. Question is, a coin is tossed infinite number of times. The probability that the fourth head probability that the fourth head appears ninth and 10th toss is, appears at fourth head appears at 10th toss is, okay. Basically what he is asking you is, a coin is tossed infinite number of times, okay. What is the probability that you will get fourth head appears at 10th toss, okay. So the options are 0.067, B is 0.073, C is 0.082, and D is 0.091. So you can very easily say that this is also going to be similar to your binomial distribution. So let us see that. If you guys want to try, you just try out once and then we'll see the solution. All right, let us start. So tossing a coin, right? Tossing a coin. So let us say P is my probability of getting head, so that will be 1 by 2, and Q, that is not getting a head, that will also be 1 by 2. So this is well understood. So probability of success and failure we have found out. Now fourth head appears at 10th toss, right? Fourth head appears at 10th toss. It means what? It means I am telling that at till ninth toss we would have got 3 heads, right? So 3 head out of 9 tosses, and 10th toss should be head. 10th toss should be head. That's it. So what will happen? You can say that what is the probability of getting 3 heads out of 9? That is my requirement. So you know already, uh, NCR, P to the power R, Q to the power N minus R. So for 9 tosses, you need to get 3 heads. So in that case, what can I do? I can say out of 9, we need 3. Then probability of success is 1 by 2 to the power 3. And again, Q 1 by 2 to the power 9 minus 3, that is 6. Okay. And then to get 10th toss head, what will happen? The probability of getting head again. So that is 1 by 2. So 9 toss we have found out 3 heads, and 10th toss, what is the probability of getting head? That is 1 by 2. That's all. So you are going to get solution. Write it down. 9C3 is how much? 9 into 8 into 7 divided by 3 into 2 multiplied by, this is going to be 1 by 2 to the power 3 into 1 by 2 to the power 6 into 1 more 1 by 2. So that is nothing but 1 by 2 to the power 6 in 9 10. Okay. So what is the value of this particular understanding? So let's see. 2 4s are 8, you can say. 3 3s are 9, you can say. 4 is there, so I can reduce 2 2s. So that is going to be 7 3s are 21 divided by 2 to the power 8. So that is going to be 21 divided by uh, 512, right? Sorry, 256. So what is the 21 by 256? 21 by 256 is going to be 0.082. So 0.082, option C is correct. Let us take another question. Question is, a coin is tossed 10 times. What is the probability that only first 2 tosses are head? Only first 2 tosses are head. Options are, this was asked in EC gate. 1 by 2 square, B is 10C2, 1 by 2 square, and C is 1 by 2 to the power 10, and D is 10C2 into 1 by 2 to the power 10. What shall we do? It is telling you that a coin is tossed 10 times, right? So basically it is nothing but we have n is equal to 10. N is equal to 10. You know already probability of getting success, that is P is 1 by 2. Probability of getting failure, that is Q is again 1 by 2. we have to find out that what is the probability that only first two tosses are head. Only first two tosses. It means what? You need to tell that I need to get first two tosses only first two tosses as head, that is 1 by 2 to the power 2, and rest all should be tail. It means all should be q, that is 1 by 2 to the power 8. So since both are 1 by 2 1 by 2, so it may be little confusing, but this is my head and this is my not head, that is tail. Okay, so that is nothing but 1 by 2 to the power 10. That is your answer. Or otherwise, another method what you can do is, this guy is asking us that first two tosses should be head. It means out of first two tosses, 2C2 we need, right? 1 by 2 to the power 2 and q will be 0, right? So I can say q will be 0. 1 by 2 to the power 0 into next all the 8 tosses, like out of 10 2 are done, so out of remaining 8 all should be tail. It means what? 8C8 1 by 8C0 1 by 2 to the power 0 into 1 by 2 to the power 8 minus 0, that is 8. Q, it should be q. So this is the complete required probability. So you can say it is nothing but 1 by 2 square into 1 by 2 to the power 8. That is nothing but 1 by 2 to the power 10. Understood? So this is how you try to understand the problem. Let us take another question. The question is, this was asked in last year's GATE, the number of accidents occurring in a plant. In a month follows Poisson distribution. In a month follows Poisson distribution with mean, that is mean value is 5.2. The probability of occurring of less than 2 accident, probability of occurring of less than 2 accidents in a randomly selected month is. So what is the probability that a randomly selected month we will have less than 2 accidents, right? So the options are given as 0.029, and then option B is 0.034, and option C is 0.039, and option D is 0.044. So take a moment of time and try to solve it by yourself. You know already what is Poisson distribution and what is the probability using Poisson distribution, right? So we have mean value, that is nothing but your lambda parameter, right? So lambda is 5.2. Now this is Poisson distribution. So in that case, what we can see is, we know already that probability of getting, let's say, K success or R success, whatever it is, okay? So X equal to R is nothing but lambda to the power R or we'll write it like this: e to the power minus lambda, lambda to the power r by factorial r. Right. So from here we are going to get probability that if it is going to have less than 2 accidents, right? So less than 2 accidents means what? We need to find out x less than 2. I'm not going to put equal to, okay? So that is nothing but we are going to have probability x equal to 0 plus probability x equal to 1. And with this, you know already, this is the formula for x equal to r. So for x equal to 0 and x equal to 1, we can put it like this: e to the power minus lambda, or lambda I can put it the values, right? E to the power minus lambda, that is 5.2 into 5.2 to the power 0 by factorial 0, plus e to the power minus lambda, that is 5.2 into 5.2 to the power 1 by factorial 1. So you can say e to the power minus 5 by e to the power minus 5 by 2 plus 5.2 into e to the power minus 5 by 5.2, right? So if you take out e to the power minus 5 by 2, 5.2, e to the power minus 5.2 into 1 plus 5.2. So if you find out what is exponential of e to the power 5 by 5.2 multiplied by 1 plus 5.2, that is going to be equal to 0.034. Okay. So alright guys, hope this helps you to understand what is my binomial distribution, or like Poisson distribution or geometric distribution. We'll take few more questions. So till now, thank you.